Thanks, everyone, for attending this talk about developing machine learning for impact. I'm Ana Villa, and I'm a machine learning product manager in Adevinta, specifically in the marketplace of Infojobs. You might be wondering, what does a machine learning product manager do, and why the need for such a long name for a job title? Let's say that I'm just a regular product manager, but in a team that is focused on developing machine learning-based solutions to integrate afterwards to the product, in our case, Infojobs platform. So let me briefly start by introducing you to Adevinta. So in Adevinta, what we try to create are what we call perfect matches, which is matching some users that are looking for something to buy with some other users or people who are looking for someone to sell something to. We are in 11 countries, and in those countries, we're trying to help support circular economy and also reinvent a bit how people sell and buy products online. Over those 11 countries, we have around 25 local brands, including Leboncoin in France, Subito in Italy, Fotocasa or Infojobs in Spain, and also here you might know in Netherlands, Marktplaats. Overall, all these local brands make up to 2.5 billion monthly visits, which is a lot. And because of that, we have somehow a lot of data and possibilities to explore. Okay, so why this talk about developing machine learning for impact? Infojobs is a job board, so it's a place where we will find people searching for jobs and companies posting job offers, trying to find the talent for those positions. This type of marketplace, like in general job boards, has, or at least how I see it, they have a complexity that other types of marketplaces don't have. And it is about how we have to deal with a lot of, let's say, plain text. And when I say plain text, I mean that at the end, people looking for jobs, what they tell us is their CV. And the CV is a lot of text that tells us their experiences, their studies, their skills, their career path, and things like that. And then on the other side, we have the companies that post these job ads that also have kind of plain text, in that case describing the job position, what is expected from the role, and the requirements that someone has to satisfy in order to be successful throughout the interviewing process. So there is this complexity when, as a job board, you want to, most of the value you can offer both to the people finding or looking for new job opportunities and the companies looking for talent. The value you can provide, or part of the value you can provide as a job board, is being able to understand if a curriculum or a CV or this candidate is relevant or not for a given job offer, and the other way around. So if a job offer is actually relevant for a person looking for a new job opportunity. Because of this complexity dealing with a lot of text and trying to figure out things from this text and understand it properly, in part because of that reason, there is a quite mature, really mature machine learning team within Infojobs that has developed machine learning solutions for years, and most of them are actually very well integrated within the platform, offering and unblocking several features in the platform, and therefore causing real impact both to people looking for jobs and to companies looking to have this talent. So this talk is about a bit like the experience from that team, in which I'm currently the product manager, and also my personal experience over the years as first data scientist in other companies, now as machine learning product manager, in a way to put it in a way to actually show the main learnings that a team trying to develop machine learning for impact has learned over these years and over all this experience throughout the developments. So the first learning that I'm going to talk about is machine learning as a tool, not a solution. And well, here's ChatGPT. I feel like I can no longer talk about machine learning or artificial intelligence without mentioning ChatGPT. Just to have an idea, raise your hand if you have ever tried ChatGPT. And raise the other hand if you use ChatGPT like frequently, let's say at least once a week. Okay, so almost everybody is like a frequent user of ChatGPT. And probably other than just using ChatGPT like in your personal life, let's say, or like to, I don't know, help me write this or rewrite this sentence, help me write this LinkedIn post, or play a bit with it to understand like how it imagines or hallucinates sometimes with the responses it can give you. Probably you have also thought on how ChatGPT can be leveraged or other tools like generative AI, how those can be leveraged in your company or your day-to-day work. Probably if you're more like a tech profile, you will have thought something like, well, this is so cool, I have to develop a project using ChatGPT. And maybe if you're more from the business side, you will have said, and I have heard that a lot, well, we have to develop AI, competitors are doing it, we cannot fall behind. And what I'm here to say is to be like really careful when we start thinking about a project or an initiative from the solution instead of starting thinking from the problem that needs to be solved, or in the case of product management, usually the user pain that we want to be solving. Together with that, what can happen is that you already have a current initiative that you are developing. And in that case, let's say it's kind of okay to go and ask yourself if this type of new technologies or tools actually help you accelerate or unblock certain things that you had in that initiative. Overall, how I see this, like in an ideal scenario, is that you want to start from the problem, but then have people in the room with enough context on this type of technologies to be able to say, hey, this problem is perfect, or a potential solution for this problem could be using ChatGPT or generative AI or whatever other machine learning technology. And to make that happen, what needs to happen is for people in the teams, people in the company to actually know about these technologies, to have enough sensibility to understand when they can be a good option as a solution and when they cannot. Things that work in that direction are things related to data or machine learning literacy, small workshops, or even like dedicated, let's say, generative AI days like the one that we had in Adevinta, Spain, to actually tell anybody who was interested about what was generative AI, what it was important, why now and not 1 year ago, and what were the different possibilities that the companies were exploring to actually leverage these new technologies into existing products or into new products. Okay, so the second lesson is less is often more. And let's say that now the problem is clear, like we start from the problem. And it feels like quite obvious to say this in the tech world, but think agile. And I say this because in machine learning, many times it's really hard to start small. Like machine learning, and we'll see later, deals with a lot of complexity when we treat a project or an initiative. And because of that, sometimes I've seen this like agile applied in tech, but not so much in machine learning teams. So even in that situation, it's important to think about how could an MVP look like for your machine learning initiative. And it's actually great that the previous talk from Bert was about, I think, a very cool MVP that he mentioned when subtracting the 3 minus the 7, well, a number minus the average number he had computed as a kind of really heuristic, easy way for a first approach without using ML. This could be a way to actually understand if something like that solves a problem, and then decide if it is worth iterating that solution by integrating or adding on top of it machine learning magic, let's say. Other ways to kind of think about that is the typical thing about the vertical slice, where you want to do the minimum work necessary in each of the steps of the project in order to be able to test the end-to-end really fast, gain the feedback, and move on from there. So to wrap up this part of it, like think agile, even if in ML it is not that usual to do so, or it's harder than maybe in other disciplines. In this step, I think it's also really relevant to think about whether it makes sense to use ML or not. And here is a bit some of the reasons why you might not want to consider ML as a solution for the problem to be solved. So it could happen that there is not enough quality data for your model to be trained. In the case that we had from the previous talk, we had all this perfect labeled data of the numbers and the characters from like, I don't know, it was American, but whatever, right? So we had this data, but sometimes this quality data doesn't exist, and therefore it is very hard for the model to actually learn what it needs to learn, and therefore be useful, let's say, at all. We will deep dive on this topic afterwards a bit. The second reason why ML might not be a good idea is levels are hard to get or unclear. And this, again, is about how you need to have, or usually for ML, you need to have some data that is labeled to give examples to the model on what it needs to learn. If you don't have that, or if this labeling is really costly, both from the time perspective, but also from money perspective sometimes, then maybe also ML is not really the best solution for the problem. Deployment and feasibility. This is about how you might need to consider how you're gonna use the model to actually unblock the use case that you want to unblock. So in that case, what can happen, for example, is that you need a model that actually runs in real time and has an input from whatever microservice to actually predict and afterwards input the predictions into another microservice and so on. Like this gets really complex in terms of deployment, and maybe the team or the company is not mature enough, or the machine learning platform not mature enough to actually make that deployment feasible. So this is something to consider also before jumping into ML in terms of, will the deployment of this model be feasible to satisfy the requirements I have for this all to work. The fourth thing is high stakes. And this is about how machine learning will always have a level of error. If a machine learning model doesn't have errors, like in the predictions, something went wrong. In the project, in the development of the model, in the training, somewhere, something went wrong. There will always be errors, and therefore, for processes or use cases that require no errors, where you cannot fail, where there are these high stakes, machine learning, again, might not be the solution. Ethics are important. We need to think always about whether it really makes sense to automatize certain decisions or certain processes through the use of ML. And here, it's really usual to hear the part of data is the new oil. And it is true. And like in a way, it's great because we have this amazing potential from a machine learning perspective, thanks to all this data being the new oil. But also, how I like to see it is how data is actually many times people. So it's the people that are interacting with an application, with a platform, with whatever, and we're encoding that information into data. So somehow it really makes sense to also see the part of the people behind that data when considering certain applications for machine learning or artificial intelligence. And the last one is need for explainability. And here is about how in some use cases, you need to be able to explain why a certain decision was taken or how certain things were automatized. And the problem many times with machine learning, and we will see it increase as models get huger and more complex, is that usually the models are a black box. Like we are not really able to understand what's going on inside them. And therefore, like, it's true that there are some techniques to make models more explainable, but there still will be some edge cases, some weird things, some not so explainable things happening with the model. So for cases where this explainability is a must, again, maybe ML is not the right tool there. So this is actually changing a lot in the last months, and I think it's really interesting to give it a thought on what's coming, right? With all the generative AI tools and techniques that are coming out, some of the, let's say, pains or limitations about machine learning are disappearing or changing. So for example, for the data parts that I was mentioning, so mainly not enough quality data and levels hard to find or predict or define, there are some techniques that are starting to be developed on top of generative AI that are called zero or few-shot learning, that are able to actually produce these data sets for the training of another model, let's say afterwards, through prompting. So in a way, this could be reinventing a bit or changing a lot like the limitations, but also the type of work that a scientist need to do when developing models. Also, for the deployment and feasibility, we now have a lot of companies and tools that are offering super powerful models through simple and really easy to integrate APIs. So again, like maybe we no longer need, for certain use cases, like a super machine learning platform within the company, because we will be using as a service models that other companies are offering. And then the last points, for high stakes, this will still be important. Who hasn't seen ChatGPT hallucinating their answers? Ethics and needed explainability, the same. So as more companies and products integrate tools like generative AI, there will be an increased level of ethics that needs to be considered. And as I was mentioning, because these models are so huge, the explainability that can be done on top of them is very, very limited. So this is definitely a problem. Okay, so number 3 was without data quality, there is no ML. And this is actually a deep dive on the first point, actually related to data and the labels and the quantity and the quality. But it's so important that I felt I had to just deep dive a bit. This is a classic in ML, so this is read as garbage in, garbage out. And basically what it means is if your data is garbage, your model and predictions will also be garbage. This is important because, again, we will want to do ML, but many times the limitation when doing ML is with respect to the data. Do I have enough data? Is it quality enough? Do I trust my data? And from there, we can understand if we do ML or not. This is so important that there's even a movement inside machine learning or artificial intelligence, which is called data-centric AI, which in the last months, years, has tried to give the same value to the data or even more value to the data in the whole machine learning project than the algorithms itself. And this movement is was actually started by Andrew Ng, who you might know, and was one of the first online teachers of ML and co-founder of Coursera. So again, right, like the importance on the data will also come from understanding, do I have this level data? How easy are these levels to be obtained? Do I have enough data to train my model? Do I have enough history of data to compute the features and the variables or the target that makes sense to be computed? And finally, from the more ethical perspective, there's this part on could my data have any sort of bias that makes my model learn to be discriminatory against certain segments of the population? So these are all data-related questions, kind of from the quality perspective, but also from the understanding of that data that we need to really understand before moving on to developing properly the models in machine learning. Okay, so learning number 5 is related to surviving the machine learning uncertainty. And here the point is that a bit how I see it is that machine learning at the end means trying to predict something that we don't know is predictable. So we start a project and we'll be like, yes, we will predict whatever, and this will allow us to do something else, right? But this we will predict whatever. When you start a project or when you start thinking about the project, you don't really know if it will be feasible or not. And there are questions that you would want to understand before starting a project because of that, right? Like, will my features or variables be good enough or predictable enough for whatever I want to predict? Will the model perform with enough quality in terms of the predictions and accuracy and center metrics that it will actually be useful for the task I want to actually use it? And because of all this uncertainty that we are not able to know beforehand starting a project, what happens is that, or how this translates into a project or a machine learning initiative, is that when we check at the machine learning lifecycle, which is nothing else than how the different phases of a machine learning project are usually structured. For, let's say, other types of projects, the phases are just sequential, right? Like, you will start one phase, you will go to the next one, and the next one, and the next one. What happens in the machine learning projects, because of that uncertainty, is that from the first phase, which would be business understanding, to the second one, data understanding, and then data preparation, modeling, evaluation, and deployment, you will see arrows pointing to the next phase. But at any point of the project, you will also see arrows pointing to a previous phase, because at that point, you might realize, oh, well, my features weren't good enough. I have to go back and check again the data and see if I have a more relevant data source. Oh, well, my model is not good enough for the predictions, so maybe I need to rethink what I want to predict to make it more simple. And this is a complexity that machine learning teams need to have in mind, because it means many things, but mainly, or at least from how I see it, it means that it is really hard to plan initiatives beforehand. Like, you cannot say, yes, for this machine learning project, we will take 1 month, 5 days to the business understanding, 5 days. This doesn't happen, or I haven't seen it happening ever. And other than the planning part, there's also how the company sees this type of projects. So a bit how it makes sense to see machine learning is as this type of projects that are like high risk, high reward. And because of that, in a way, they should be treated as, well, allowing them to have enough space without a lot of pressure in terms of deliverables or dates, because you have seen these complexities, this uncertainty. They will not be met, and you might need to just, like, stop the project before reaching any significant results or impact, just because there were these hard dates on deliverables and dates. Okay, so number 5 is on the importance of multidisciplinary teams. And here, the main point is that predictive models no longer stay in the data scientist laptop. And I say no longer because not too long ago, this was not the case. Like, for example, when I started as a data scientist, let's say 5, 6 years ago, in a different company, the laptop did stay in my the model did stay in my laptop, and I would run the model, export the predictions in a CSV file, send the CSV file to someone to integrate in a database, like this type of process. Let's say that I'm not super proud of those moments, but I think that was the reality in many of the companies starting to do machine learning, because there didn't exist, maybe except for like big tech companies like Google, Amazon, and so on, there didn't exist like what we know now as machine learning platform or proper platforms to do the whole end-to-end development of models. So fortunately, this is no longer the case. But this means that the teams working on machine learning have had to change and adapt to that reality. And that change usually means that you need multidisciplinary teams that actually will be able to develop the model, but also deploy it and integrate it to the processes of the company. Okay, so this is an example of a multidisciplinary team, our machine learning team in Infojobs. And what you can see here is that the team is formed mainly out of 3 data scientists. So the 3 data scientists, their objective or goal is to actually develop properly the models. That work includes usually like exploring the data, defining the features, defining the model, developing properly the model, and evaluating it. And usually this happens like now in Python, some years ago also in R, but I think that kind of died. Then we have 2 machine learning engineers who would be the people in charge of taking that model and actually deploying. This usually means making an API available for someone to request from an input a prediction from the model, and that API to return the predictions for then whatever use that needs to do. There is also a backend engineer whose role is to act as a bridge, let's say, between that machine learning engineer deployment of the model and the rest of the backend-driven platform in Infojobs. And finally, there's me, in this case, machine learning product manager, and I have the role more about helping the team understand or define the strategy, priorities, vision, and so on, and also kind of sync with other product managers, business stakeholders, and so on to ensure at the end that our solutions will be useful and with impact. Last but not least, we also have the support of a UX researcher. In that case, she helps us. I say she puts voice to our customers, so she helps us understand further the user pains and therefore move in the kind of right direction towards solving those pains, and also helps us sometimes like with UX surveys and gaining at the end qualitative data when we do new models, versions of the models, and so on. So definitely relevant on that. And the data analyst, who is the person more close to the data, doing certain analysis, dashboards, and usually helping us out when doing experimentation. Okay, so the last learning is what is not measured can't be improved. And here we'd be at the point where we have developed our model, we have put it into production, we have integrated the predictions with the processes of the platform thanks to this multidisciplinary team. And here we want to ask ourselves, like, what impact has our model brought to our product or company? And sometimes it's easy to say, okay, well, this is a completely fake example, by the way, but it helps illustrate. So, okay, so the sales were going this way, and at the moment where we put our new model in production, they started to grow. So kind of cool, like our model did a great impact, and all these sales increases thanks to us. So this is not the right conclusion. Because at the end, like the explanation on that growth could be anything, really, like a new ad in TV that worked really well, an influencer doing a super campaign about your product, a competitor leaving the country, like, I don't know, like there many reasons can influence that, and you cannot actually separate that impact from the one that you did by deploying the new model. So to avoid this type of wrong conclusions, experimentation is a must, but also in ML, like it is in any tech company, but also when developing ML. And what experimentation or A/B testing allows you to do is to see the two walls. Like it allows you to see the wall and how it evolves, where you didn't add or deploy this new machine learning model. And on the other side, see also the wall and how it evolved where you did deploy the machine learning model. And the cool thing or magic about experimentation is that you can actually compare the tools. And in this case, what you would see is that actually the fact of deploying your new model caused a negative impact in sales. And again, like the increase that you were seeing since the moment of the deployment was due to external factors to your team. A note on this, this is interesting for when you are just launching a new feature or a new model that will be integrated with some processes, but also when iterating existing models. What is really frustrating, but kind of makes sense, is that usually not necessarily models that have a better offline performance actually bring further or better value in the real online world. So because of that, even if it is clear offline that a model is better than the one you have in production, experimentation is still a must to understand if that improvement offline actually means something or not online. Okay, so this is, well, a bit what we saw in terms of learning. So to summarize, I mentioned one, machine learning as a tool, not a solution. 2, less is often more. 3, without data quality, there's no ML. 4, surviving the machine learning uncertainty. 5, the importance of multidisciplinary teams. And 6, what is not measured can't be improved. And with all these learnings, you might be asking, okay, but what has this really meant for Infojobs and the machine learning team in terms of the impact that working with these learnings or experience has been able to be leveraged? So here are, I will follow with 3, let's say, success stories from Infojobs on how the development of machine learning has been integrated in the platform and let's say, positive impact that they have caused. So the first success story is about recommendations. And basically what happens is that we have some recommender systems, machine learning based, that offer list of recommended offers for candidates or people looking for jobs. These lists are integrated in several touch points of the platform or of the app or website. And some of them you can see here. So the first one is in the homepage. So when you open the app, you appear in the homepage. The first thing that you see are offers recommended for you, powered by one of these recommender systems or a variety of them, depending on the user. And then the second slide is actually when you check, okay, when you actually check an offer like it is doing now, it's charging. So if you go at the end of the offer, you also see a list of recommended offers. In that case, offers that are similar to the one that the user is checking at the moment. The pain that this different list of recommenders was trying to solve for the users was something related to there are no offers for me, or it is really hard to find relevant offers for what I'm looking for who I am, and so on. And the impact, we can see it as it is, well, the different recommender touch points are one of the main sources of applications in the platform. And also, if we compare the performance of these touch points, for example, with product metrics like click-through rate, conversion rate, and so on, we see that the performance of these lists are really good versus other types of discoverability components. Okay, so success story number 2 is CV parsing. In this case, we have a machine learning model that from a PDF, that would be a CV from a candidate or someone looking for a new job opportunity, would parse the information in that PDF. And this process is then integrated into a way to suggest the user to add relevant information to their Infojobs profile. So how it works is a bit like what is shown here. The user is able to upload the CV is processed and parsed, and then comparing the information we have already from that person with the one that is parsed through the model, we decide if it makes sense to suggest, hey, you haven't added this experience, why don't you add it? It could be relevant for making your CV more complete and updated. And the cool thing about that is that most of the information will already be provided as it was scrapped from the CV. The pain this was trying to solve was something related to the sign-up is too long, it's time-consuming, editing and updating the CVs is not cool, like it's really time-consuming. And in terms of impact, now we have seen sign-up processes that are faster, but also CVs that are more complete. And even if that was like an extra from solving the pain, it is really important because at the end I was mentioning before how it's important for us to be able to understand the matching between a CV and an offer. And if we don't have a CV updated, then probably we're not going to be able to compute this matching like the best we can, let's say. And also for the companies, it's interesting to see like updated and complete CVs because otherwise like they might think that the person doesn't have an experience when in reality the person does have it. Okay, and the last success story is what we call normalizations. And this is the use case, let's say, that is more related to this matching problem and this, let's say, kind of main or primary value that we're adding as a job board, which is related to understanding if a CV is relevant for an offer, if an offer is relevant for a CV, right? So other than the whole idea of plain text and how you figure out what the CV and the offer are talking about, asking about, and so on, there is a complexity in the language itself because many times, or almost always, people will refer to the same concept using different words. And here you have an example, right? So we could have a job seeker whose CV or resume says that the job experience is programmer, and then you could have an employer whose job offer is asking for a software developer. We as humans know that this is the same or very similar, but of course, like the machine or our processes don't know that if we are not able to tell them. So what we do is, through machine learning, we are able to classify into a common classes that are structured as taxonomies or hierarchies, both the experiences and other information from the candidate and the job titles and other characteristics of the offer, so that we're able to put them in the same, let's say, way of writing or way to understand, and this way we're properly able to understand if there is this match or this relevancy in between. So this was actually trying to solve like an internal problem more than a specific user problem, which was it is hard to know if there is this match between experiences and job offers. But the truth is that actually solving this more from a core perspective has enabled or improved many features like the searcher, the recommenders, and many other features through the use of this, let's say, more intelligent way of understanding what the CV is talking about, what the offer is talking about. Okay, so that was it from my presentation. Thank you so much. Here you can see some links from Adevinta in case you want to find out more, the webpage and also the social networks.